Alright, chapter 5 is all about polynomials and polynomial functions. So throughout this chapter you're going to learn how to manipulate these polynomials and find the solutions of the polynomials just like you have with linear functions and quadratic functions. And we're also going to be looking at the graphs of these functions. We're going to see what they look like. But before we do any of that awesome stuff, first you have to have a strong foundation of the properties of exponents. So that's what we're going to be looking at right now. So let's look at something you already know. You know that x to the fourth equals x times x times x times x. You're just taking that base, which in this case is the x, and you're multiplying it however many times this power or exponent tells you. So if you had 7 to the third power, it would be 7 times 7 times 7. So now let's look at some properties of exponents that you might not have seen before. And in these properties, just like properties of anything else in life, a property of water is that it's liquid, a property of a cheeseburger is that it's solid. A property is something that's always true. So whenever we're working with these exponents, these hold true. So let's look at these properties. First off, with all these properties, a and b are going to be real numbers, and we're going to let m and n be integers. So in this case, our powers are going to stay as integers. So let's look at our first property, the product of powers property, which just says that you're taking a real number to an integer times another real number to an integer, hence the name product of the powers property. So what you're going to do is, let's use some real numbers here. If we had, for example, 5 to the third power times 5 to the negative 1 power, what you're going to do to rewrite that is take the base, which in our case is 5, and you're going to add the powers. So we would have 3 plus negative 1, and if we simplified that, that would just be 5 squared. And this is in exponential form. If they ask you to solve it completely, your answer would be 5 squared, which we know to be 25. The next property is the power of a power property. And in this case, what you're doing is you're taking a power to another power. So if we had some number 3 to the power of 3, so 3 cubed, and that whole thing was to the power of 2, or that whole thing was squared. What you're going to do to rewrite this is take your base, which is 3, and now instead of adding your exponents, you are going to multiply them. So you're going to have 3 times 2 now as your new exponent. And if we simplify that, that would be 3 to the 6th. 3 times 2 gives you 6, and 3 to the 6th power is actually 729. On to our next property, the power of a product property. And in this case, what we're saying is if we have two real numbers, multiplied times each other to some power, we can rewrite that as that base times the power times the other base times the power. So let's use some real numbers again. If we had 2 times 3, and that was all to the 4th power, what you can do is you can rewrite this as 2 to the 4th power times 3 to the 4th power. And if you were to find this answer, if you did 2 to the 4th times 3 to the 4th, you would find that to be 1,296. Essentially, it's kind of using the distributive property almost. The next property is the negative exponent property. And what this is saying is if you have some real number to a negative exponent, what you're going to do is basically just flip that, and you're going to put that number over 1, and that makes your exponent positive. So if you had, for example, 7 to the negative 2 power, what you do is put that in the denominator, and that makes your power positive. And again, you know what 7 squared is, that's 49, and we'll talk about that more later in class, why it works out that way. But right now we're just going over the properties in general. The next property is the zero exponent property. All that says is anything to the 0 power gives you 1. Pretty simple. If you had negative 89 to the 0 power equals 1. Anything to the 0 power equals 1. That one's pretty simple. Next one is the quotient of powers property. Now we're saying that if you are dividing two numbers to a power, you can rewrite that as whatever your base is, and now you're going to subtract your exponents. So before, when you were multiplying, you were adding your exponents. If you divide, you're going to subtract your exponents. So for example, if we had 6 to the negative third over 6 to the negative 6. To rewrite that, we take our base, which is 6, and we take our exponents, which is negative 3, and we subtract them, so minus negative 6, which gives us 6 to the third, and if we were to multiply that out, 6 times 6 times 6 would be 216. The last property we're going to look at is the power of a quotient property, and it is similar to the power of a product property that we just talked about, wherein as you quote-unquote distribute your power through to each real number. So in this case, we're going to be looking at a quotient instead of a product. So if we had 4 over 7, and that whole thing was squared, what this property says is that you can rewrite that as 4 squared over 7 squared. And this is exponential form, and we know that 4 squared is 16 and 7 squared is 49. And those are the properties that we will be working with this chapter.